Hi everyone, welcome to Fisher's Ideal Index Number, a discussion on index number calculations. This is a continuation of my earlier video and it is topic number 5.9. Fisher's Ideal Index Number. This is another method of weighted aggregative method which I have discussed in my earlier video. Professor Fisher's introduced an ideal method for constructing the index number. And Fisher's index number is the geometric mean of Laspeyres method and Bast method. Laspeyres method of price index. Let's just discuss a little bit about that. Laspeyres price index is a weighted aggregate index based on the base year quantities of respective commodities. So basically Q0 is coming into the picture. Q0 is the quantity which is consumed by a family for different types of item in the base year. It attempts to answer the question, what is the changes in aggregate value? Aggregate value means price into quantity of the base period list of commodities when price of the commodities at given period or the current year are considered. So what basically Laspeyres method is giving you an idea. Suppose the quantity consumed by a family in 2010 and in 2020 are not changed, but still you will see the expenditure of the family has increased because of the price has increased for each type of item or commodity. I mean, P1 might be greater. Most of the cases it is greater, sometimes even it is lesser, like electronics item. But if even considering the same amount of quantity consumed in the base year or current year, how much is the change in the overall expenditure or aggregate expenditure? That is done by the Laspeyres method of price index. So to easily remember, Laspeyres method is basically based on Q0. Okay, there is another method which is called Bast method of price index. Bast method is again based on the current year quantity Q1. If you remember, then you will not confuse, because other thing P1 by P0 always price index means current year price by the base year price. So P1 by P0 is not changing. For Laspeyres it is Q0, for Bast it is Q1. So Bast method of constructing index number is a weighted aggregative index based on current year quantities of the respective commodities. It provides an answer to what would be the value. Value means price into quantity of the current period group of commodities when compared to the base year prices. So the formula is summation P1 Q1 by summation P0 Q1 into 100. Now, if I take the geometric mean of both these method of price index, we'll get Fisher's ideal index. As you see, the first case, the quantity of the current year Q1 is missing. Whereas in the Bast method, the quantity of the base year is missing. So it's not giving you a complete picture. Whereas Fisher's ideal index is square root of summation P1 Q0 by summation P0 Q0, which is Laspeyres thing, into P1 Q1 by summation P0 Q1, everything square root and then outside multiplied by 100. That will be given by the that is used for calculating Fisher's ideal index method. So basically Fisher's ideal index method is square root of Laspeyres method into Bast's index. Yeah, and outside that definitely both the 100 will multiply, so square root, so it will come in the outside. So that is what is the Fisher's ideal index method. This above formula for computing price index is also known as cross weight formula, as it is taking both the base year and the current year weights. Now, Fisher's index is one of the best method for calculating index number, and it is called ideal method. Why it is called ideal? The first thing, as I already discussed, it is based on the base year as well as the current year, both price and quantity. So price of base year, price of current year, quantity of base year, quantity of current year, all are considered in the formula. This is based on geometric mean of the last pair and the past year's method. And as you know, theoretically, geometric mean is one of the best method to calculate average. Then it satisfies the time reversal test and factor reversal test. In my next video, I will discuss in detail what do you mean by time reversal test and factor reversal test, and how Fisher's ideal index is actually satisfies both of them. Time reversal test is whether you are changing the formula into base year to current year and current year to base year, the formula will not be impacted. Whereas factor reversal test, if you are interchanging the price and quantity, it will not be impacted much. That's why these two are very important properties of Fisher's index. And this is free from bias because we are considering all the things. Neither we are giving more weightage to the current year quantity, nor we are giving more weightage to the base year quantity. So it is taking care of all of that. Now we will do Fisher's index by using a formula. Let's see the question. Calculate the Fisher's index number for the year 2010 with 2000 as the base year. So the price for 2010, sorry, this will be price for 2000 and then price in 2010, that is P1, quantity in 2000 and quantity in 2010 is given. So P0, P1, Q0, Q1 all are given for the 4 types of commodities. We have taken a very simple example, just 4 items are there. So let's see how to calculate Fisher's price index. So therefore we need to construct 4 more columns, which is P1, Q0, P0, Q0, P1, Q1 and then P0, Q1. Each item, if you know, P is price, P0 is price in the base year, Q0 is the price in the quantity in the base year, like that. And then we are multiplying P1, Q0, so 30 into 15, 450, 24 into 84. You can see, 24 into 2480, like that we have calculated P1, Q0 and we have got the summation as 1177. Similarly, P0, Q0, which is 21 into 15, 315, 12 into 18, 216, like that calculated. P1, Q1, we have calculated 30 into 14, which is 420, 24 into 20, 480, like that we have calculated. And P0, Q1. P0 is 21 into 14, so calculated 294. Then 12 into 2240, and we have got the summation of all of them. Now, using the formula, please remember this square root is still here, the 100 is outside. So we are just putting the value P1, Q0, which is 1177 divided by P0, Q0, 681. Again multiplied by 1305, which is P1, Q1, divided by P0, Q1, which is 744. We take the square root and multiply, we are getting 174.11. What is this value? This value is to buy the same amount, whatever you could buy by 100 rupees in 2000, you have to spend 174 rupees in 2010. So that's all about this video. In my subsequent video, I'll be discussing about some more problem of Fisher's index number, how to calculate. I will also discuss about the FRT and TRT in that video. Please follow. Thank you.